Hi, my name is Pe. I'm a software engineer. I'm a software engineer based in Johannesburg, and today I'd like to talk to you about component-driven development. We'll explore the inherent complexity in software systems and understand what components are. We'll discuss the benefits of the component-driven development approach, and finally, we'll examine some trends that are built around this idea. Attributed to Larry Wall, a linguistics enthusiast um, who created the Perl programming language, is this idea of the waterbed theory, which states that systems tend to have this minimum level of inherent complexity, at which point, if you try to reduce this level of complexity in one part of the system, it tends to increase in another part of the system. Take the case of GraphQL, for instance. We want to make it easy for front-end developers to receive the data they want in the structure that they want it from the server. However, this increases the complexity of the server, right? We have to handle more dynamic and complex queries. We have to optimize for data fetching and, excuse me, but somehow still manage to obtain a good performance, right? In this case, we've simply moved the complexity from the front end to the server side. What is CDD, right? Well, let's break it down a bit. What is a component? Quick Google search will tell you that a component is a constituent part of a system. Of course, by development, we mean software development, right? Software being nothing but a collection of programs, and development being this procedure which brings something from a state to a state of fulfillment. That means, right, or hence, component-driven development is a procedure that brings a collection of programs to a state of fulfillment. There are various ways of determining what the state of fulfillment is. Often it's business requirements, but yeah. Picture how car parts are manufactured, right? Yeah. Picture how car parts are manufactured to build an entire car. Okay. Why adopt component-driven development? What's in it for me, right? One reason might be to separate concerns. The idea is that decomposing a system into self-contained subsystems helps us manage the complexity of the system at large. From this alone, we realize benefits in onboarding, testability, auditing, among other things, right? In the case of onboarding, it's easier to onboard new developers to work on your new project, right? They can begin to contribute towards the system and incrementally learn more complex parts of the system. With respect to testing, there are often times where you'd like to delegate the responsibility of testing to a party other than the authors of the components. For instance, a QA team. These testers focus on separate parts of the system, right, as they test the application. From my own personal experience, I found this to be an effective way to learn to learn a large system, right? Then you have auditing, right? When you have a system that is easy to onboard, in which it is easy to onboard new people, right? It also tends to be easy to have your peers and colleagues to review your programs, right? You can leverage this feedback to improve the quality of your programs. All of that just by separating concerns. Let's go to usability, right? Using components like buttons, inputs, or dialogues can help in ensuring a consistent user interface. It can also help you in enforcing a brand identity. For example, if you take Google or Google's material design system, right? You know it's a Google product just by looking at it. And this is due to how they reuse their components from their design system. In general, using components means you only have to build these components once and you only need to test them once. Right. Next, resistance to change, right? A business's requirements are always evolving. We need a flexible system architecture to keep up. Take, for instance, a online marketplace like Amazon, right? Amazon should be able to easily update their components, right? Like their shopping cart components or their payment processing components without having to overhaul the entire site. Right? Minimizing coupling between components is crucial here. Changes to the payment processing component should not break the shopping cart components. This ensures that each component can evolve independently, ensuring that your system is able to continuously change and evolve as well to keep up with the business needs. A system like this is less resistant to change. Let's examine some trends in the component-driven development space. We will focus primarily on web technologies. A technique where, code splitting, sorry. This is a technique where an application is split up into chunks, advisably logical chunks that can be loaded on demand. This improves the initial load times of an application, right? And sorry, yeah, this improves the initial load times of an application. For example, when you are browsing your Twitter feed, right? You're not always concerned about your subscription plan. So you might not necessarily want to load these components initially. So instead we'll only load the feed page, which is what you're focused on. Have a look at server-side rendering. This is a technique where our components are used to render an HTML document on the server side. You might want to do this if you want to reduce the user's time to interactivity with your site or your application, right? The user can engage with the static contents of your application without having to wait for the JavaScript of your application to load. This also assists with search engine optimization as search engines are able to index a complete HTML document instead of an HTML document with an empty body and a whole lot of JavaScript. The drawback of SSR is that there isn't any interactivity, right? Your page is completely static. The way to fix this issue is with hydration, right? The process is similar. We still render our components on the server side and generate our documents. The front end or the clients will then render this, you will render this document initially, but then afterwards it will then download the necessary JavaScript or the necessary it will download the necessary JavaScript. Once it has executed it, it will then attach the necessary event listeners, and initialize the application state, so that you can achieve that level of interactivity that you intend for your users. After this hydration process, the user is able to perform the fancy interactions that you've intended, right? Sorry. Okay. The issue with partial hydration is that loading JavaScript or loading and executing JavaScript for an entire page tends to be very slow. So you want to split up this approach a little bit more. This is where partial hydration comes in. Right? Partial hydration is an optimization on hydration, which allows you to, instead of load JavaScript for an entire page, you just load JavaScript you just load the business logic for a single component at a time that appears on the page. This can dramatically improve the load times of your application, right? Let's take an example of a blog. With a blog, you might want to render the static content of your site initially, right? The user can then engage with the static content while the page is being hydrated with all the fancy interactions. Furthermore, to optimize this hydration process more, then you can decide that you want to selectively hydrate just a single component, such as the comment section of the blog, right? Great. So we're able to render our components on the server side. We're able to achieve the level of interactivity that we'd like to achieve. However, there's still an issue here, right? So we still have to compute our HTML document twice, once on the server side and another time on the client side. A recent development is that of resumability. I struggled with this one a little bit personally. I still do. That's mostly because the terminology used to describe this process it doesn't accurately capture what is going on for me. Essentially, when the HTML document is produced on the server side, it is then embedded with additional data about the application state and the chunks needed to add that level of interactivity that you need. This embedded HTML document is then serialized and sent as a response to the client. The client is able to then display your page using this embedded, is then able to display your HTML documents and then use this embedded data to initialize the state of the application. When the user then clicks on a button, for instance, the client will then try to download a chunk of code that will then handle that event. The result of this is that the HTML document is only computed once. This technique of resumability, it improves the load times and the bundle sizing of your application. Okay, so we've discussed the benefits from a project management perspective, and we've also discussed the benefits from a non-functional requirements perspective. In the case of the non-functional requirements perspective, we observe that in creating a better user experience, we end up creating a more complicated application. Reducing complexity in the client-side rendering, we then introduce complexity in the server side. This trade-off is the whole point of this talk. Right? There's a sweet spot when trying to manage complexity, and it's not always easy initially to decide where to allow for complexity or where to prevent complexity to grow. A good place to start is to analyze the resources that you have. You want to analyze the experience level of your team. You want to decide how long you're going to work with that team, what kind of application you're building, right? Are the fancy interactions of your application going to be the selling points, or is it going to be the static context, like in the case of a blog? One way or another, you'll always have to find yourself, or you'll always find yourself dealing with some level of complexity on the fly. The important thing is to be able to adjust this complexity. And I believe a component-driven approach is a good way to go about this.